Thanks, Lebo. Okay, so let's start with a 10-mark old exam question. And I'm going to let you do this pretty much by yourself now. So I'm going to give you 5 minutes or so, and you're going to do this by yourself. There is one thing I want us to notice about the data set. First of all, what is different about this data set compared to the types of data sets we've been dealing with recently? And then what else do we notice about this data set? So maybe someone can even come online and just talk us through kind of how is this different to the stuff we've been doing recently? And what else is special about this data set? Who would love to give us their insight? Any ideas?
Anybody?
In the chat. So I want to notice, so I've jumped to an old exam question. The last time we were together, we were doing something called ogives. And so I want to know, first of all, how is this question different? And then even when you look at the data, what do you notice about it? Okay, Loretta has made a very important point. The data is not in a grouped data table. So we call this a list of data, right? Or a sequence of data. It's not in a grouped data table with frequency and so on. So that's the first thing to point out. We've gone back almost to the beginning, like the first 4 lessons. There's something else about the data, though, that I want you to notice. And we want to calculate things like the 5-number summary. It's not in ascending order, or it's not in ranked order. So in order to answer this question, the data actually needs to be, in order to work out, the first question is to draw a box and whisker plot. You first need to have your data in order and calculate the 5-number summary, which is the min, the max, Q1, Q2, and Q3. So let's just make sure everybody kind of has the right, this data set has to be arranged from smallest to biggest. So 10, and then I think I've got 55. So take a moment to arrange the data from smallest to biggest. What have we got? 60, we've got 70. 78. Oh, no, I've gone too far. I missed 75. And then I've got 75, 78, got 80. I've got 2 80s. 2. Okay, so before you start, that is the correct order of the data. And that should help you answer these questions. Off you go. And if you have questions, I want you to raise your hand and we will discuss them. But I'm keen to see how this goes out of 10. What would you get out of 10 for this question? How many items do we have? We've got one. Okay, we've got 12 items in our data set. So n is 12. Okay, so what I did was I worked out the positions of Q1, Q2, and Q3, but I haven't got my values yet. And so I'd like to know them from you guys, if you can help me work them out. And from there, we can do the rest of the question. So for Q1, I know it's position 3, or it's between 3 and 4. So it's going to be over here. Let me get rid of it for a second. So we know it's going to be between 60 and 70, because that's for position 3.25, which means Q1 should be 65. Now, so what are we going to get for Q1, Q2, and Q3? So I agree. That's going to be 83. And that is going to be 79. Okay, so if you've got that as your 5-number summary, I now want you to try and draw me a box and whisker plot from that data. And I also want you to get me my interquartile range. Looking good, Oratile, looking good. So I'm just going to get rid of this calculation for a second. So whenever I draw a box and whisker plots, I know I need a number line below. And so since my smallest number is 10 and my biggest number is 90, I think I'm just going to go from 0 to 100. I think that would be fine. And let's see what we get if I just do that. So let's say it's 0. What's my box and whisker going to look like? Okay, I'll keep those answers coming in. So 65 would be over here. So let's go like that. 79 would be about here. 83 would be about there. 90 would be there. Actually, let me draw my box. And then the lower one be all the way down here. Okay, so my box and whisker plot definitely goes more one way than the other. And let's see those answers coming through. So what is my interquartile range, and is the data skewed or not? Those are the types of questions I want to see you answer in the chat. So interquartile range is just going to be Q3 minus Q1, which is going to be 83 minus 65, which is 18. Awesome. What about data skewness? Is this data skewed or not? And is it skewed to the left or to the right, positively or negatively? So this data set is skewed to the left, or we could say it's negatively skewed. So I'll say negatively skewed. And that is because the lower 50% of the data is much more spread out than the top 50% of the data. So it's negatively skewed. All right, things are looking good, guys. Now, what about, is 10 an outlier? How would we check? Can you remember how we check for outliers? What was the formula we have to use? Who can come online and tell me the formula for checking for Lesedi, go for it. There's something called a lower bound and an upper bound. In this case, because 10 is at the bottom, we need the lower bound. Do you want to raise your hand, Lesedi, so you can tell us how to find the lower bound, or put it in the chat? Okay, so to find the lower bound, or the number which something has to be below to be an outlier, you just take Q1 and you minus 1.5. Oh, wait, Loretta's getting there. Minus 1.5 times the interquartile range. Yes, Loretta, exactly that. So I want you guys to tell me, is 10 an outlier? If 10 is less than this lower bound, it is an outlier. If it isn't, then it's not an outlier. So try and figure out the lower bound first, and then compare it to 10. You have all the values that you need already. You know IQR, you know what Q1 is. Okay, so IQR was 18 and Q1 was 65. So 65 minus 1.5 times 18. I need to know what that value is. And that value is 38, which means the lower bound, the dividing line for outliers that are small, is 38. So is 10 an outlier? 10 is an outlier, yes. So 10 is an outlier because 10 is less than 38. So therefore, 10 is an outlier. Yeah. Okay, so just remember that for future questions, if you want the lower bound, it's Q1 minus 1.5 IQR. If you want the upper bound, it's Q3 plus 1.5 times the IQR. Are there any questions or comments before I move on? Any questions or comments before I move on? I'm going to do a different question now. Okay, you handled that pretty well. So that was good. Let us do this next question. This is a 12-mark exam question. However, it has something called the standard deviation in it. And so I want to see, just first, let's do these two questions together first. So we're going to do those two, and just give me the answers for those two first, and then we'll move on from there. I want to see that you know how to use your calculator to find the standard deviation. The data set is already arranged in the correct order. So you don't have to rearrange anything. Let's try and do that. Okay, Mbali, I see what you've got there. I agree with you. Stephanie, you would use, if it was positively skewed, you'd use Q3 plus 1.5. So if it's going up and above, you use plus. If you're going to a low value, you use minus in that formula for outliers. So I hope that answers your question, Stephanie. So the range indeed is 70. So remember, when you get the standard deviation, you first have to hit mode. So I'll tell you the steps. You go mode, then you go stat, and then you go 1 for var, and then you put your data set in. So you go 5 equals 8 equals 15, and you put all the data in, and then you hit AC. And then after that, you have to go shift stat, and then you choose 4 to get into the sort of the var menu again, and then you choose 3 for your standard deviation. So we did cover this in video 3, and this should be 19.56. So we covered this in video 3, how to calculate the standard deviation of a data set. So again, I'll go through the commands. You hit mode 2 for stat, then you hit 1 to go to the loading your data. You load all your data. You hit AC. You then go shift 1, then you go 4, and then you go 3, and then you go equals to get standard deviation. Okay. Assuming that's good with you, and if there aren't people who are happy, then let me know. Let's try and do question 1.3 and 1.4 next. Yeah. So same as before, you just need to calculate the positions of these numbers. So the Q1, Q2, and Q3. But how many? 5, 6, 7, 8, 9. Okay, so Q1's position will just be 9 plus 1. Oh, that should be position. Sorry, I shouldn't be saying. Okay, so keep going, guys. So your median is in the 5th position. So the 5th position, the value of the median is going to be 25. The median is 25. What is my interquartile range going to be? That's the next one I want answered in the chat. What's the IQR? And then once you've done the IQR, you can go on and do the box and whisker plot. Draw the box and whisker plot here. So the Q1 value is going to be position 2.5. So that's going to be halfway between here and here. And then the Q3 position is 7.5. So it's going to be halfway between here and here. So I need to average out the values to get each of these. So Q1 should be 11.5. And Q3 should be 33.5, which makes my IQR just Q3 minus Q1, so that should be 22. So IQR should be 22. Awesome. Okay, draw me my box and whisker plot, guys and girls. And then after you've drawn the box and whisker plot, I want you to answer 1.6 and 1.7. And then I will show you the model answers and we can compare our model answers. Try and do those last 3 questions by yourself. Did you write this in your maths test last week, Basedi, this exact question? Oh my goodness. Oh well, I hope it went well. Well done, Basedi, well done. That is a good achievement. You can be proud of the hard work you've been putting in. Okay, so I want to know, once you've drawn your box and whisker, I want to know about the skewness of the data. Is it skewed to the right or the left, or positively or negatively? And then I also want to know about, are there any outliers in this data? So the only values that could be outliers, look at the box and whisker and ask yourself, does one of the values look far away, and how would you test it? I'll show you the model answer in a moment from the exam paper. When you are done with this 1.5 to 1.7, just say done in the chat so I know kind of where you guys are. And then I will reveal the answer when I feel like enough students have had enough time. Okay, so some people are making claims about outliers. Let's see if you can, what you guys think. Describe the skewness of the data, and are there any outliers? Look at your box and whisker plot to help you. Okay, so what does our box and whisker plot look like? And please go back up for 2 seconds. Okay, here we go. Is that helpful, Paul? Okay, let's have a look at the answer here. So what was our final answer going to be here? Here is the model answers. So our box and whisker plot should look like this. There's a very big sort of tail going to this side. So the 50% of the upper 50% is much more spread out than the lower 50%. And so the box and whisker should look like that. And we say that that is skewed to the right or positively skewed. And now we have to ask ourselves, basically, you can see if there's going to be an outlier, it's going to be up here. And so how do we check if the maximum value 75 is an outlier? Well, what we need is we need our upper bound. So how do we get the upper bound? We go Q3 plus 1.5 times IQR. And so in this question, Q3 was, where did I work it out? Q3 was 33.5 plus 1.5 times 22. And if I think about what that gives me 66.5. And then I compare it and I say, is 75 greater than that? And it turns out 75 is greater. And so 75 is an outlier. Okay. Are there any questions, students of my class? Are there any questions or comments or things you want clarified? that was, again, a proper exam. This looks like it's from an old exam. Yeah, might even be from a trick exam paper. So the level is getting good now. Okay, no questions. I don't see any raised hands. Then I think we know what it's time for. It's time for a stretch. Oh, percentiles. Okay, Tony, I will see if I can work that into the rest of this lesson. Maybe I can even work a percentiles question into this one up here before we move on. Okay, let's take a quick break. So I don't understand how we should use outliers. In Bali, what I would suggest with outliers, it's just a criteria. So you just need to get used to this formula of basically for an outlier which is really big, you're going to use this formula, Q3 plus 1.5 times IQR. And for a really small outlier, you would use the formula, you would compare it to Q1 minus 1.5 times IQR. So you just need to look at those formulas and compare them to those upper and lower bounds. Okay, let's have a break. So I want everybody on their feet, turn on your cameras, and Lebo, if you could please encourage our students to stretch it out. I'm going to stretch it out because, oh, my body needs it.
Come on, guys. Give your mind a break.
Oh, I can't tell you, missing out. My body is so happy with me right now. It's like.
Shout out to Boje.
Oh, that feels good.
Come on, guys, don't be shy. I hope you're stretching even if your camera's off.
Do the hemisphere crossing thing where you put your hand on the opposite leg. See if you can do that. Get your brain like moving, and then see if we can do that one. Yeah. Or if you really want to be sneaky, you do this. Remember that one from a while back. Okay. Cool. I hope that you had a good stretch. Do the splits. Well, if you can do the splits, then you're more talented than I am, afraid.
That's levels.
Yeah. But I'm very happy for you if you can do them and still be happy afterwards. Okay, let us do a brain break. Different type of brain break today. This is a bunch of scrambled letters that make a mathematical word. I want you guys to try and tell me what this mathematical word is. So what mathematical word? Oh, Barbara, settle down. Anemika, you're so quick. This is subtraction. Wow, you guys were not slow on the uptake there. Okay, here's another one. Tell me what the mathematical word for this one is. What is the mathematical word for that one? Sure, guys. Okay, so clearly next time, so the mathematical word is arc. You are getting these very, very fast. I wonder if I can grab one from my sheet that's a bit harder, because I feel like I haven't given you your full. Okay, let's do one more. I'll just grab it quickly and find it. Can you guys work out this? Can you work out this one? And then we'll go back to class. But what is the mathematical word you make from that one? Oh my goodness. He's so quick. It is indeed triangle. Triangle. Well done, Inam. Well done, Bochle. I'll see if I can bring some harder words next time. But you are clearly pretty good at this type of stuff. Okay. I hope that you had a good stretch. If you haven't, just quickly before I move on to my lesson, stand up, stretch your legs out, touch your toes, do something to tell your body you're alive, because we really are asking our brains to do a lot now. It's getting late in the day, and we really need to kind of give it a little burst of excitement. Okay. So on our journey through past exam paper questions, I wish for you that you get this question from an old exam. Try and do that question for me now. It's 4 marks, and I want you to do that. And then when you're done with it, say done in the chat. So write down the 5-number summary. In fact, who would like to even, maybe somebody can even come online and tell me what is the 5-number summary for this data set? Who's feeling like raising their hand? Okay, yeah, let's go to Mason. Mason, what is your 5-number summary for this data set?
Minimum is 12.
Perfect, yep.
Q1 is 17.
Perfect, yeah.
Q2 is 30.
Perfect.
Q3 is 38.
Yep.
And maximum is 65.
You're winning at life. In fact, you're doing so well. Let's just do this whole question. What's the interquartile range for this data set?
It's 21.
Perfect, because you just went 38 minus 17. And can you tell us, Mason, about the skewness of the data? What do you think about the skewness of this data set?
It is skewed to the right.
Perfect. Skewed to the right, or we can say it is positively skewed. Perfect. Perfect. All right. I think that question went a little bit too quickly. I think you guys have all got that. So are there any questions or comments before I move on? I hope that you get a nice one like that in the exams. Okay. Well, then let us go on to, let's move on to a grouped data question, but let's do something a bit different. Let's do something like this one. Okay. So you're given the following exam question from an old exam, and you're given an ogive. I want to know 2.1.1. How many, these are players at a soccer tournament. I want to know how many players took part in the soccer tournament. Okay, so I hope you're all scanning your ogive and you look to the very top and you go, what is it in line with? It's in line with 50. And so 1 mark in the bag. Okay, now, second question. Determine the number of players between the ages of 24 and 31. What are the number of players between the ages of 24 and 31? I want you to try and zoom in on the graph and think about how many players between the ages of 24 and 31. So we've got age along the bottom axis. And so where is 24, where is 31 is the hint. So 24, there are 10, it looks to me like there are 10 students who are less than 24 years of age. And where's 31? 31 is over here. So there are 40 students who are less than 31. So how many players are there between 24 and 31? So that's going to be basically all these players. And so what is the final answer going to be? How many players are between 24 and 31 years old? So 24 goes with 10, you're right. So basically there's 10 players that are younger than or equal to 24, 40 who are younger than or equal to 31. What's the final answer going to be? It's just going to be 30. So it's going to be 40 minus 10, which is 30. And that's how many players basically are in this. Let's get this. This age group, 24 to 31, that's the age group. But to get the number of players, I have to go to the other axis. Okay. Give me a thumbs up if that makes sense. Thumbs down if it doesn't make sense. Just want to get a quick check-in. Okay. Let us move on to the second part of the question. And this is a bit more sneaky. We're not going to do the whole thing here, but we'll do some of it. I want you to work out the frequency column. So what are the numbers going to be in this frequency column? I'll give you a hint. This first one is 4. I think you're onto something, Loretta. Yep, that's going to be 9. What are the next ones going to be? So I have to ask myself, what do I need to get to? So to go from 13 to get to 37, I'm going to have to go 14, huh? No, sorry, 24. Whoopsie daisy. 24. 13 plus 24 gives me that. That one's going to have to be 10. And then this one is going to have to be 3. Oh. Okay. Now, sometimes they do it like that. They almost give you one of the columns and you have to be able to work backwards. So it's important that you know how to do that. Now, I'm not going to ask you to draw a frequency polygon now. There isn't enough time. But what I am interested in knowing is with a frequency polygon, there's some important stuff that you need to be able to calculate. So first of all, if you're drawing a frequency polygon, whereabout in the interval is your point going to be for a frequency polygon? Now, when we learned about this in class, the frequency polygon we often linked it with the histogram. But if you draw it with just points, it's the middle. Yeah. So what I would do is you do also need a point. Okay. Just like the other things, you draw an extra column for point. And in that point, you're going to choose the middle of that interval, which in this case is going to be 17.5. And for this one over here, it would be 22.5. For this one, it would be 27.5, but we're not finished yet. We still have to add the other coordinate of the point. So what are we going to pair these points with? What's the y coordinate going to come from? Is it the cumulative frequency or the frequency for the frequency polygon? Kind of gives it away, doesn't it? It's not the cumulative, Himali. So for the frequency polygon, it's going to be the frequency column, which makes sense when you think about it, right? It's not cumulative frequency curve, it's the frequency polygon. And so this value over here is just going to be 4, 9, 24, 10, and then 3. So these are going to be the points that you would basically, you'd basically join them, and you don't join them with curved lines, you join them with straight lines. There was one other thing about a frequency polygon that you had to do. Does anybody remember? So if you were drawing it with histograms, the way we did it mainly in class was we had histograms and we went to the midpoint of the histogram, but there was something extra which we did. Can anyone remember what that was? So we've got most of the points in our frequency polygon. We need to ground the points, yes. So if we were doing it from a histogram, the grounded points would just be an extra interval on each side. Okay, so what would an extra interval look like? Well, we'd have an interval that goes from 40 to 45 here, and we'd have an interval that goes from 10 to 15 over here. Now, we need, in order to get back to the ground, we're going to have the frequency of 0. And so essentially what we have is we'll have a point 42.50, and over here we would have 12.50. And all that would do is it would get us basically back to the ground again. So Loretta, it wouldn't be 0, 0. It would actually just be 12.5, 0, because we have the interval on each side. So I'll show you what that looks like, because we're not going to have time to do a full one. But basically the frequency ogive would look like that. And so you can see the extra, interval that I added over here. That was this one here. And then you can also see 10 to 15 over here. And you can see how it's back to 0. The rest of the points are just 17.5, 4 would be about here. And you can see there's another one there, another one there, another one there. These are the points that you were doing up here. Ah, you're right. So I will go back now and look at a percentile question just to help you guys. But before I do, I know we haven't a lot of frequency polygons, but basically the most important idea is where is the middle of the interval, generating your point, and then adding an interval at the beginning and at the end. So before I do a percentile question, are there any questions about frequency polygons? Okay. Give it a moment or two more, then I'm going to go and do a percentile question. Okay, so let's just talk about percentiles for a moment. Let's go back to a previous question. So earlier in the lesson, we had this collection of items, of data sets. So if I wanted to find, let's say I wanted to find the 60th percentile, how would I find that for this particular data set? Now remember, at the moment, there are 9 items. So the way we find the 60th percentile is we just find the position of P60. So we do the position calculation, position P60. And that's going to be 60 over 100 times n plus 1. So n in this case was 9. So 9 plus 1 is 10. So what is 60 over 100 times 10? It is just going to be 6. Make sure I've got that right. Yeah. So in this case, the 60th percentile would just be the 6th position. Now, it doesn't always work out to be exactly like that. So maybe I should even have said the 65th percentile. But at the moment, the 6th position would be, the 60th percentile would be 1, 2, 3, 4, 5, 6. So 27 would be the value of P60 or the 60th percentile. But I suspect what you wanted me to do is rather to have like a more messy one. So let's say, what about if I want the 65th percentile? If I wanted the 65th, or let's do that, 65th percentile. So then what I would do is I'd say, okay, I want the 65th percentile. This would be 65. In fact, let me make it even messier. Let me make it, instead of 65, let me make it the 72nd. What is P72? So P72 would be the 72nd percentile, and that would be my calculation. And now what is its position? It is going to be 72 over 100 times n plus 1. N is 9. So it's position 7.2. Now, how do we find position 7.2? Well, when we deal with percentiles, we don't average out. We go to the nearest value. So what is the nearest value? It's 7. So this is the 7th position. Okay. What value is in the 7th position? So that is going to count at 1, 2, 3, 4, 5, 6, 7. So the 72nd percentile is just going to be this value over here, 31. And the thing with percentiles that is a bit different is that we don't average out the values. We go to the nearest one. And since 7.2 is closest to 7, we go to the 7th position. Does that help a little bit on percentiles? Or would you like me to try and find another one? Give me a thumbs up if it helps. Give me a thumbs down if it doesn't. Okay. Let's see if we can get one more question in. What can we do? Well, let's do this one. Let's finish with this one. So 6 marks, old exam question. Off you go. See if you can do these ones. Last question of the day.
Mr. Ace?
Yeah.
So no, there was a hand up, but she put it down.
Okay. So the mean, the good news about the mean is I just literally add them up and divide by the number of items. So what are we getting for the mean? You can use your calculator, but it's so 2, 3, 4, 5, 6, 7. So there's 7 items. What do we get? So that should be 9. Your mean should be 9. What is the standard deviation of these scores? So people are getting, let's just see if I agree, 2.2. Some people are getting 2.2, and you are correct that the standard deviation should be 2.20. Now I want to know how many of, so Taylor's scores for the last 7 netball games she's played are as follows. How many of the Taylor scores are within 1 standard deviation of the mean? So this is an interpretation question where you have to say 9 is the mean. How many scores are within 1 standard deviation? So if I'm within one standard deviation, I could go up or I could go down from the mean. So if I went up from the mean, I'd get to 11.20. So basically 9 plus 1 standard deviation gets me to 11.20. 9 minus a standard deviation gets me down to 6.8. So I want to know how many schools fall within this range. How many fall within this range? So it's not going to be that one. Is that one? Is that one? Oh, wait, it's not 13. I lie, because 13 is outside the range. So 8 is in the range. 13 is outside. So I could even put it here, like 13, 6 is outside. How many are within the range of 1 standard deviation? Is 11 in the range? It is. Is 9? Yes. Is 7? Yes. Is 9? Yes. So there are, how many are within 1 standard deviation? There are 5 out of the 7, or just 5 are within 1, 5 items. Okay. Cool. I think that is it for tonight. I think we've done well. I will go and look for some more old exam paper questions for the next lesson. The one that we didn't do today was the estimated mean. So we must make sure we do the estimated mean in the next lesson. And I'll go and look for any other types of questions that were different to today's ones. But yeah, it was fun teaching you guys tonight. Lebo, if you could please put the link to our poll in the chat. And thank you guys. It's been great teaching you.